Hello, I'm Danny Ryan. I work with the Ethereum Foundation on Eth2 research, specs, and a lot of coordination on the project in general. And today I want to talk to you about some things in the Eth2 roadmap a little bit further down the line, and some of the challenges and some of the trade-offs that we've been thinking about. And to start off, I'll also give you just an introduction to Ethereum 2.0 to kind of ground you in the architecture. So we just finished at DevCon, which was, super exciting. It highlighted much progress, especially on Ethereum 2.0. Last time at DevCon, we were really just first getting some basic specs together and getting the various teams and people involved in the project. Sorry. But we also had many discussions at DevCon, which highlighted a lot of confusion and concern about different parts of the roadmap and how it may or may not affect users, may or may not affect developers, and things like that. After DevCon, one of my goals is to better communicate the technical roadmap to you and developers in general, and to discuss the trade-offs, and to also give clear indication about the path that we plan to take following these trade-offs. So today, I'm going to talk to you about the general Ethereum 2 architecture, just get everyone grounded in that. This new shard proposal, which we're actively working on, which has some really nice benefits. Execution environments, or EEs, what they are and why they may or may not be a good thing. And a two-way bridge between Ethereum 1 and Ethereum 2 during the development of Ethereum 2. Technically how we might do it, and also just the various trade-offs about when and why and how we may do it. So, as I said, we'll start with just general look at the Ethereum 2 architecture. So this, in a nutshell, is what we're building. It's very simple, obviously. It's divided into phases of development. And so we can look at each phase of development to help better understand the system and how the different pieces link together. What we call phase 0 is just really a pure proof of stake chain. So we have the existing Ethereum chain is that proof of work chain, the pink chain at the top. It keeps chugging along, and we build this new chain in parallel to it called the beacon chain, which is, as I said, a pure proof of stake chain. And it serves as the system level infrastructure, the system level chain that kind of links everything together in the new sharded structure of Ethereum 2. And so what happens in phase 0 is really, we have validators that live on the beacon chain. They build the beacon chain. They finalize the beacon chain. They participate together to create random numbers through a process we call RANDAO. And in general, just kind of get the core infrastructure together such that the rest of the system can be linked onto it. There is this tie to the existing Ethereum chain, but it's single directional in that deposits can be made into the beacon chain to become a validator from Ethereum 1. But you can't at this point move ETH back into Ethereum 1 if you say you were done validating. So phase 0, we have many teams working on this very actively. Specifications are in a very stable place, although there's a couple changes I'll discuss later. And people are working on testnets and interoperability between clients. Cool. So phase 1 is when we add the shard chains to this system. The shard chains being, each one of those you can think of as, it's very similar to the existing Ethereum chain, but we have n of them, where n is to be debated and discussed. But each one of these shard chains then connects to the beacon chain. At phase 0, these shard chains, phase 1, these shard chains are just data chains. There's no sort of notion of state and state execution upon these shard chains. So there's no user level accounts, contracts, and the things that you think of in Ethereum. It's just creates a highly scalable data availability layer. These pink links back into the beacon chain, or what we call crosslinks, and they serve as kind of the routing of the shard chain back into the beacon chain, and they also serve this point of communication between the shard chains. And the new sharding proposal that I'll discuss in a moment discusses like the trade-offs on the frequency with which you might make these links. So at this point, you have validators building the beacon chain, and you also have validators sampled into committees to build these shard chains and to link them back, references of the shard chain back into the beacon chain, kind of unifying the system. Phase 2 is where you add this notion of state and execution upon these shard chains. This is where you get the things that you think of in Ethereum today, accounts, tokens, balances, transfers, contracts, all those types of things. And specifically, the path that we're taking right now, or at least deeply investigating, is stateless execution, rather than the more stateful execution, which exists in the existing Ethereum chain. And I'm going to discuss that in a couple of sections from now. So really, it's beacon chain is the system. We connect all of these shard chains to it. These shard chains are very similar to the existing Ethereum chain, and thus we get some multiple and scalability by having a number of these shard chains in parallel. Some of the intricacies and trade-offs come in how we actually connect them to the beacon chain and how we allow them to communicate. And the last part of phase 2 is I don't know what phase this is, maybe 2, maybe 2.5, at which point the existing Ethereum chain disappears, gets rolled into this system. This is the final form. Cool. So that's Ethereum 2. It provides a scalable data availability layer and many multiples in scalability compared to today. But I want to talk to you now about this other thing that's coming up on the roadmap and has been a big point of discussion in the past, really just three or 4 weeks. And it's this new shard proposal. And one of the main benefits is it's a better UX, but at what cost? So previously, crosslinks, the things that link shard chains back into the beacon chain, would happen on every epoch. This is once per 6 minutes. And we would have 1,000 shards, 1,024. And because of this cross-linking happening only every epoch, you end up with, at layer 1, a epoch-length cross-shard latency. So if I want to communicate from shard 1 to shard 2, I might have to wait approximately 6 minutes, and if I want to communicate back, I have to wait another 6 minutes. It's definitely not a great user experience, and potentially also a tough developer experience. And there's all sorts of problems that arise around paying for transactions and where you have ETH and which chains. And we're investigating all sorts of more complicated ways to evaluate state and optimistically determine state on different shards to help facilitate better communication. And I'll get into that in a moment. So this is what it looked like. This has some pretty bad latency, so hopefully this will go okay. But we had the beacon chain would be built. This crosslink was formed to this chain, chain A, we'll call that other chain, chain B. And then crosslink is formed to chain B. At the point that the crosslink was formed to chain A, now you could make proofs about things in chain B. So say a transaction happened and went into there, but now we have to wait until a crosslink is formed to chain B before we can communicate back to chain A. And so this is only happening on like a couple of blocks, but actually this would be 64 blocks at potentially 6-second slot time. So you have like a lot of lag time in how these crosslinks are formed. Like, you know, this crosslink, that's crosslinked, this epoch happens, that epoch happens. And so because of this, you can have more shards, but you have a lot longer latency. In the new proposal, we're discussing cross-linking every shard at every slot and reducing the number of shards to 64, at least to start. We can discuss that in a moment. But the really great thing is this proposal allows for cross-shard transactions to happen at the slot latency. And so instead of waiting 6 minutes for a transaction from shard 1 to hit shard 2, we can make a transaction on shard 1, and the immediate next slot, something around 10 seconds, we can have the communication happen, the ETH transfer, the contract call hit. And so we can facilitate a much better user experience. And so this new proposal, more concretely, looks like the chain's being built in parallel as normal, but at each beacon chain slot, we can point to a new shard block to facilitate communication. So if at the second beacon chain block we link to here, then the next blocks know about the new beacon chain state and can facilitate consuming transactions and receipts of transactions from each one. So pretty much at every slot we get a nice communication infrastructure through the beacon chain. So some benefits. Funny enough, fewer shards at the beginning ultimately ends up a reduced complexity, and so actually might be a benefit in getting these things out to production in time to market. Certainly a better user experience and potentially even a better developer experience. Just things still don't happen cross-shard with atomicity, but you can potentially have a better developer tooling and languages to deal with this quicker guarantees of latency. And we ultimately think by moving this proposal, because of some of the reduced complexity in the amount of shards and the complexities in dealing with cross-shard communication, quicker time to phase 1 and ultimately phase 2, which I think is a net benefit to the community. It also reduces the need for complex fee markets. We've been discussing all sorts of like, if I have ETH on shard 1, but I want to participate on shard 2, I need to get ETH over there to participate in the fee market, which has quite a high latency, which like induces some bad UX. So we had all sorts of like burgeoning proposals on how to handle the complex flea markets, but because now you can move ETH in a single slot, it reduces much of the need for these fee markets. It also reduces the need for dealing with optimistic state. Optimistic state being in shard 1, I create a transaction. I know it's going to affect shard 2 at some point, so maybe I can then give that information about it affecting shard 2 optimistically and kind of like push state along in shard 2, and then only ultimately when the cross-shard communication does happen, it resolves the state. But anyway, these are very complex models that we were looking into, but this greatly reduces the need for looking into these, if not eliminates them altogether. So major benefit. Certainly some trade-offs. So we've been discussing having 1,024 shards for over a year now. So having fewer shards to start would ultimately reduce the total scalability. But there's some caveats to that, and I'll get into in a moment. We also likely might have longer slot times because we want to have more rounds of communication per slot, because we want to have essentially the beacon block created, shard blocks for that slot created, attestations, and then a new beacon block, rather than having shard blocks built at exactly the same time as beacon blocks. This to just help the lag time on the communication between shard blocks. Okay. Some other trade-offs, things that I've been thinking about a lot because I work with a lot of the, sorry. Because I work with a lot of the implementers and the implementation teams that have been working on interoperability and working on test nets. This is something that's been keeping me up at night, is that this requires some changes to phase 0. And if we didn't change things at phase 0, then when phase 1 would come, we'd have some legacy code that we have to deal with. And it could lead to a delay in phase 0 test nets. This is largely mitigated by having a subtractive phase 0 release. So instead of in phase 0 having the infrastructure for crosslinks, essentially just cutting the crosslink infrastructure out, such that we can kind of keep everything moving forward and not have to worry about testing this new idea before phase 0 continues forward. So the current thoughts on this proposal are it's pretty, the win on the developer experience and the user experience seems too high for us to not go down this path. Also, there's some recent research that, Starkware did on large blocks, I think blocks 512 kilobytes, testing large blocks on the Eth2 network. And the uncle rate, the propagation times were very good and the uncle rate was very low. So we're pretty sure that we can have fewer shards but larger blocks to facilitate a similar amount of data availability than the original proposal when we had 1024 shards. So still something on the order of 1 megabyte to 3 megabytes of data availability per second. And we have a PR up for review right now that's largely just subtractive from phase 0 to ensure that we don't have engineering delays on the phase 0 release to testnets and production. Cool. So it's one thing that we've been thinking about and talking about a lot. This is another one. Execution environments. How abstract can we get? And is it worth it? So previously in ETH2 designs and in the current Ethereum 1 chain, we have this like very stateful model in the sense that the core consensus assumes that it has access to all of the state at all times to both read from and write to. So the execute, and also the notion of execution, the notion of transaction, the notion of counts, the notion of the tree structure, all and the data structure is all like very deeply enshrined in the consensus. So what does that actually look like? So this is kind of a glimpse into this model for Ethereum 1, where we have the state. Within the consensus, we have access to the state tree, and we have this like one execution engine that has hard-coded rules about execution, transactions, and the account model and structure. And then we have the chain that kind of like just has transaction data, and we use the consensus to execute on this transaction data to modify and update state. So, but now we're looking at this model we call execution environments, which is both a stateless model, and it's also highly, it makes execution highly abstracted and generally extensible. So there's really two things happening at once in this proposal. It's a move to stateless and a move to abstracting execution. So what does this actually look like? So in the previous model, we had state and we had hard-coded rules. And instead, here we have this like blob of, we have the state root, so it might be 32 bytes representative of the state or a digest of the state. And we have this like execution code that is WASM code that can be specified on like more of an on-demand and user level. And so, and in our chain, we have our normal transaction data, but we also have what we call witnesses, which is essentially showing up in the block with the database that you need to execute that actual transaction data against the state. And not just the database, but the proofs that that data is valid with respect to the current state root. So what does that actually mean? It means if I want to transfer value from account A to account B, I can't just assume that my transaction that says move 5 ETH from A to B, that data, the accounts and the balances are actually available. I have to prove that what this current state of both those counts are with the witness data, so that when the execution code is executing on the transaction data and the state root, it can modify and update the state root. The cool thing about execution environments is also that these aren't predetermined by the consensus protocol. Instead, they can be added by the user level. So instead of us presuming that we have all of the right answers and know exactly how accounts and execution should be built upon Ethereum, this is now like an extensible item, such that it can grow and evolve over time. And the really nice thing, one of the really nice things here is that it gives us a nice migration path for Ethereum 1 into Ethereum 2, because we can actually fork Ethereum 1 into Ethereum 2 as an execution environment. So essentially take the existing state root of Ethereum, put it into here with an EVM interpreter and Merkle witness verifier as the execution code. So some of the benefits is because we end up taking a lot of the complexities of how state should operate, how rent, all these various things out of the core consensus and move it into layer 2, we might actually be able to have a faster time to market because we don't have to spend, we can continue to research these concepts and develop these concepts after the core consensus is rolled out. And it allows this scalable data availability engine to be used in any number of ways. So this core base layer we want to be used for decades and decades to come, and I think to presume that today we know exactly how it should be used and how it should be structured, we don't actually know that. And so this just kind of allows it to be a little bit more future-proof. Right, so layer 1 becomes a little less locked in. It can just be as like a general scalable data layer. It allows for experimentation over time, clear path from ETH1 to ETH2. And future-proof in the sense that it creates more abstraction between the various layers. And so, like on the internet is built of a number of protocols that are just layered on top of each other, such that some of the, thank you. Essentially, TCP IP doesn't have to change, and we can just change the protocols on top. So similarly, with ETH1, we don't have to change this data availability layer, but the actual ways in which we interact with it can grow and evolve over time. So a little more future-proof. There's definitely some trade-offs. It might be too abstract. So a lot of the conversations we had at DevCon were confusion around what this layer adds, what you should actually be doing with this layer, who should be writing EEs, and why. And so we're finding it to be, at least in these early stages, it's a bit of a tougher developer narrative. And there's some confusion around what EEs are actually good for. So we do plan on hoping to better communicate this, especially as the ideas and specs evolve. There's also some of the worries around potential fragmentation. These EEs in some respects could end up competing with each other, or you could have 5 really good EEs, but although these EEs can communicate asynchronously, you now have to deal with potential fragmentation of applications across EEs. So some things we're definitely thinking about as we develop this concept a little bit more. So the current thoughts is that it's definitely a net positive. Not definitely. It appears to be a net positive as we continue to explore it. But we still have time to experiment with the design space as we build out phase 0 and phase 1. Going to spend more time better communicating, and the future proofing, I think, at least personally, I see as a very major win for Ethereum 2. Cool. I'll quickly talk about two-way bridge. So tightly coupling the consensus of Ethereum 1 and Ethereum 2, whether it's worth it when we should maybe do it. And so essentially, I mentioned earlier that Ethereum 2, initially, there's a unidirectional bridge of ETH, such that ETH can be transferred from Ethereum 1 into Ethereum 2, but the initial architecture does not allow for the transfer back. And this is for a handful of reasons. Primarily, to do that requires us tightly coupling the development of Ethereum 1 and the hard forking of Ethereum 1 with Ethereum 2, and it also puts the two systems the risk of each affects the other. So before we deem Ethereum 2 stable and robust in production, it seems unwise to tightly couple these two things. So here just is that unidirectional transfer. We can move ETH into the beacon chain, but not back. But there ends up being issues here. We've discussed widely at DevCon. Clearly concerns from users and potential validators. It opens up questions and issues of liquidity, and it also, maybe more importantly, opens up issues of fungibility between ETH1 and ETH2. If we allow for liquidity on ETH2, so some sort of transfer mechanism, before ETH1 is forked into ETH2 or before there's a bidirectional bridge, very likely there might end up being, almost certainly, there'd be 2 tokens traded, ETH1 and ETH2, on exchanges. This is definitely a concern, both of ours and of the validator community at large, so we're looking at ways to mitigate that. And there's just, we want to encourage validation in these early phases, but there's definitely like a high risk because there's an unknown lockup period. And so also looking to mitigate that. So two-way bridge, errors in both directions. There's a few different paths that Vitalik highlighted on ETH Research recently. One is to embed an ETH1 light client into ETH2. But into the EVM, but this would require some hard forking to facilitate BLS 12.381 support, and you end up only having a light client level of security. Essentially what happens, the important part is this light client proof. So we have these ETH1 voting periods on ETH2 where we facilitate ETH1 deposits into ETH2, but then we'd also have these light client proofs about finality in ETH2 that go into ETH1 that could then, once you've proven that something was finalized on ETH2, you could consume receipts about transfers and have withdrawals on ETH1. So again, this requires some hard forking coordination on ETH1, which is difficult at times. So this is probably not the most likely path. The other option is to have ETH1 nodes run ETH2 software. So either as full beacon chain clients or just as light clients. The nice thing is that this path allows us to use the finality mechanism. So we can not only use this mechanism to facilitate transfers between ETH1 and ETH2, but we could also use it to leverage the security of the validators from ETH2 to secure the ETH1 chain. Which I think people are pretty excited about. That's usually called the finality gadget proposal. But you still need a mechanism to expose the ETH2 state root in ETH1. And so there's a couple of discussions on ETH Research on how to do that. Some might involve miners essentially like putting in the block the latest ETH1 finalized root, and people, if it's invalid if it's invalid for any reason, that people would just filter that out of their fork choice. This does also have the additional benefit of once we've exposed that state root in ETH1 and have a solid mechanism for doing that, we can use the highly scalable data availability layer from ETH2 within ETH1 to do fun things like ZK rollup and optimistic rollup. So major benefits of doing a two-way bridge is to prevent 2 ETHs from being traded on exchanges and kind of like confusing the users and validators and developers. We get nice finality, and it allows us to use the ETH2 data availability later soon. But there's definitely some trade-offs, and like I mentioned, the reason that we're not doing it initially is because ETH2, although we're very confident in the design, we want to see it proven in production before we have it affect the security and the risk profile of ETH1. We also, so that's the entangling of the security of each, but we also, the sooner that we entangle the protocols, then we actually, the sooner that we entangle the protocols, the more that the development of each kind of encumbers each other, such that the ETH1 moves much slower than ETH2 at this point because there's a lot of concerns around the actual user base, and it just takes a lot of coordination to get hard forks on our production network. So the sooner that we tie these things together, we might potentially slow down the ETH2 development in the forking cycle. And there does add some additional overhead to ETH1 nodes, although the overhead of a validating beacon chain client is relatively low. My current thoughts on this is that we likely should enable a two-way bridge before we add validator liquidity, but probably after phase 1 is stable in production. Again, there's a lot of like moving pieces in parallel that may affect when and if this actually is done. Yeah, so that's it. Thank you. We're constantly trying to seek balanced design and a roadmap and world of trade-offs.
Give a round of applause for our speaker, Danny. Do we have any questions for our speaker, Danny?
What's up? Yeah.
Hey, thanks. So when we talk about this new shard proposal and taking the shard count down from 1,024 to say 64, where does 64 come from?
Where does 64 come from?
Right. So much of the load on the beacon chain is with respect to cross-linking, with respect to bringing the frequency at which you bring shards into the beacon chain. And so in the prior proposal with 1,024 shards and epoch lengths of 64, you're cross-linking on average 16 shards per slot. And so this induces some overhead on the beacon chain, both in terms of block size and in terms of the computational cost. And so 64 ends up being, it's in that range of 16, such that it's still feasible to computationally process the overhead of all shards, of those shards into the beacon chain. The multiple comes from both the extension of the slot times and some of the computation tricks that we can do to reduce that overhead ultimately.
Okay, thank you. Last question.
Yeah, when you talk about try to prevent two ether exist, I don't know how technically you can do it. And only thing I can think about is have the ether whales sell off all the ether one, and that probably can prevent. But I don't know how technically you can do it.
Well, you can technically do it if the ETH between two portions of the system, ETH1 and ETH2, are totally fungible and exchangeable. Then there is no need for an additional token to represent the system. So if you have ETH1 and you have ETH2 and you have Ether over here and you have Ether over here and they can't transfer, then like very certainly if I have an exchange order book, like I would have these listed as two different things. But if there's a transfer mechanism between the two, it's like having ETH in different accounts or different like domains of accounts. And so then you have, like if you have fungibility, there's no need for two tokens. And if you did have two tokens listed on your exchange, like certainly you could do that, but they should trade at the exact same price because they're totally fungible with each other.
Okay, thank you. And do we have one more question over there?
All the different shards will have the same execution environments, and what would be the way for someone to propose a new execution environment and getting that in?
Right, so there's still some debate on how you expose execution environments to shards and whether there's optionality in doing that, like whether an execution environment can be specified just for one shard or it's always for all shards. But the simplest proposal is for each execution environment, you actually have shard count state roots associated with it so that it can be operated within each shard and have a state associated with each shard. And the second part of the question, how do you propose these? So similar to deploying a smart contract on Ethereum 1, and similar to maybe deploying a smart contract onto a shard, deploying an execution environment actually looks and feels and is extremely similar, if not exactly the same, to deploying a smart contract onto the beacon chain. And so there'd be some sort of special transaction to deploy this bit of code and deploy some sort of like genesis state to the smart contract or to the execution environment. But importantly, because the beacon chain if you're syncing any part of the system, you have to be syncing the beacon chain. We have to bound this state size and bound computation on this thing. So there would be some sort of high ether lockup or high ether burn to be able to deploy things onto the beacon chain. So some sort of like either burn or type of a rent model.
Okay, because from what I was reading, I didn't perceive it as being something that it can be done in a permissionless way. So that's great. So it would be like you deploy your WASM blob for how your execution environment works onto the beacon chain, and that gets kind of like propagated to the shards that want to use
Right, that becomes available to shards to execute. And when you make a shard block, you'd specify the execution environment or the set of execution environments that it executes upon. And essentially, like whatever cost it costs to deploy to the beacon chain, these execution environments, it needs to bound the state size of the beacon chain.
Okay. Thank you very much for your time. If you have any more questions, please feel free to talk to our speakers afterwards. Okay, thank you very much.